okay to not know exactly what to do. That's all right. So we'll come back to the Desmos activity after we kind of take a step back and like check on some things, and make sure that we understand like scale drawings and scale copies and how we find scales and how we use scales, because then we'll be better suited to go back and kind of draw those sort of like a blueprint of our not necessarily dream house, but the house that we want. So the first thing we need to talk about today is scale factor. And scale factor is just another way that we convert, right? So scale factor is how we change the size of something. And sometimes, like we were doing yesterday, we can convert from like boxes or units to inches or feet or miles or whatever. So on your notes to the right of that box that says scale factor, I want you to write scale factor again and draw like a line under it. And we're going to write out how we find the scale factor there. And we're probably going to come back to that. And I'm using a set that I printed out before I changed some things. You should have more space over here than what I have. But please write out scale factor. Ooh, I need to restock my jar, don't I? Look, guys, school is not over. We have a month left. This is not directed at Nate. This is directed at all of you guys who keeps, like, needing to use my pencils. That's all right. But, like, school's not done yet. So if you're out of pencils, tell your parents you're out of pencils. I bet most of you guys can just click a button on Amazon and have pencils at your house in a couple days. If not, walk yourself down to the, like, Dollar General or somewhere. They've got great pencils, like unicorns and things like that. I need to go to the Dollar General and buy someone some Kit Kats. Allie? Today, I don't know. The 7th, I guess.
Also, after like too many years, I finally got Michelle a birthday gift that she likes.
What was that?
Some DJ.
Huh. Well, there you go. Scale factor, I'm going to abbreviate it down here, is found... I'm not going to tell you. Let's figure this out together. So they tell us the order of the scale is important. And actually, guys, I have this. I'm probably going to toggle back and forth between up here and on my actual notes page. So they tell us that going, right, the omnipotent they tell us that going from my little shape up to my bigger shape has a scale factor of 2, right? They show us when the arrow's going to the right, we have a scale factor of 2. Now, what side would that 3 correspond to over here? Jocelyn? The 6? How do you know that? They're both green. Okay, they're the same color up here. Right?
It says times 2. All of these numbers are multiplied by 2.
Ooh, we've been told what to do. That we're looking for the number that is 3 times 2. And also, the angles at the bottom show us that the shape didn't spin at all. Right? The shape is still facing the same direction it was before. So guys, I'm skipping over a couple practices that are in Khan that if you need help on, come get help from me. Well, one of them is just identifying corresponding points and saying like, oh, well, if it's the top point on this triangle, it would correspond to the top point on this triangle. Or if it's the right side of that triangle, it's probably the right side of this triangle. Now, if we're trying to check that, we can check the multiplication. Now, we can scale either way, right? We can go either way with the scale factor. So if we get bigger, or if we get smaller, like if I take my 12, my bottom side, go this direction and scale it times 1/2, then all my numbers are getting smaller. So the scale factor goes either way. We can get bigger, we can get smaller. If we want to do nothing, we want to scale a shape and do nothing. What sort of scaling would do nothing?
Would it be 1?
Yeah, a scale factor of 1 does nothing. So,
1 is the original number.
yeah, 1 is the original. I love it. 1 is the original. So, guys, grab your highlighter. If we want to get bigger, scale factor larger than 1. So 1.1, a scale factor of 1.1 would get bigger. Or a scale factor of 1,000 would get bigger. Or a scale factor of 5. Or like a scale factor of 9/5. Is 9/5 bigger than 1? Yeah, it's not a very nice number. 9/5, oh, that would be terrible. That's like 1.8. Yeah, I think 9/5 would be like 1.8. But yeah, like any number bigger than 1 gets bigger. So if we want to instead get smaller, oh man, smaller than 1. I'm so surprised by that. Surprise of the century. I don't know what to do with these. I want to leave them out so you guys can access them. If you want to use colored pencils and taking notes, you can. I don't care. That's probably my wife going for a walk. I hate when my phone does that because it's my front door, but she gets to take, like, she's working from home, so she gets to take breaks and go for walks. So here's another example, but this one's not on your paper, right? What we want to talk about is when we go forwards and backwards with the same shapes. Can anyone tell me what you notice about these two scale factors? When we go from big to small, my scale factor was 1/4. When I go from small to big, my scale factor was 4. Is 4 over anything? Yeah. Yeah, it's not like the reciprocal. It is the reciprocal. So guys, scales that go backwards of each other, right? Scales that go backwards of each other are going to be reciprocal values. So instead of times 4, we don't say divide. We do not say divide. Everything with scaling is multiplication. So instead of saying divide by 4, which guys is really what we're doing, right? 20 to 5, we could say we divided by 4, but we don't, because scale factors always multiply.
So you would multiply by 1/4.
Yep.
I was going to say, like, all numbers that are like all whole numbers could really be put over 1, and because like you could usually with whole numbers, you rather than putting it as a fraction, you put it as a whole number because you can do that.
Mm-hmm.
And it's, well, not necessarily.
So this is interesting. They tell us the scale factor is 1/4. And I see, if I put 5/20, or 4/16, or, well, now they're all the same. So guys, really, what I want you to write on your paper where we wrote scale factor there at the top right, your scale factor is found, if we need to find the scale factor, by doing the new over the old. Or you can call it original, but new versus old is easier for me. This is kind of like when we talk about the image and the pre-image, but we can make our life easier and write less letters, right? Instead of saying image and pre-image, now we can say new versus old. So down here, since our new is 20 and our old was 5, how do I go from 5 to 20? Well, if I don't know how to do the multiplication, we divide and we do 20/5, and I find out that my scale factor is 4. You don't have to put it as 4/1, you can just put it as 4. Any questions on that? I didn't have space to put this on your notes, so sorry that that one is not on your notes, but I don't want to spend more paper than I need to. Oh, thank you. It makes my heart warm. It's perfect. It's a perfect circle. All right, try the next two problems here. Oh, see, I'm silly. I had these to write on. And I forgot, and I just wrote all on this one. But I had them blown up also. So these, I'm going to clear my ink so we can see the same stuff. Take a moment. Be careful, though. Double check with yourself. Are we getting bigger or are we getting smaller? So it says, what is the scale factor from A to B? We start at A and go towards B, right? We go to the B. The B is our new. Right? If you want to label, this is our new and this is our old. Oldie but a goodie. Now, should I use the what we can call straight lines, or should I use the diagonal lines? Use the straight ones, right? Don't make your life difficult. Make your life easier if you have the option. And we do. So take a moment. This is also from figure A to figure B. So this is old. Remember, if you get done with the problems on the front, you can flip to the back. Just flip back with us when we come back together. I actually have another. If you want to pass out papers for me. This is the next set of notes that we're probably going to get to today. I just didn't want to make you guys grab two different pieces of paper. So, if we want to set up the division, I need to figure out my lengths. Anybody, how long is this side? 6? Yeah, I don't even know what to call that shape. Like quadrilateral, I guess, because it's got 4 sides. How long is this side on the old one? 2. So if I put my new over my old, what does that simplify out to? 3. Because we got bigger, our scale factor here is times 3, right? Figure B is our new shape. We got bigger. It's the opposite in the next one. Find a couple lengths that we can measure. How long is this edge? 4. How long is this edge? Okay, so if I say that the scale factor is the new over the old, 2 over 4. What's that reduced to? This is 1/2. So notice, scale factor more than 1 gets bigger. Scale factor less than 1 gets smaller. Questions? I'm fantastic. I bought a drill press last night to help me with Mr. Cabillo's project.
What is the project?
So a drill press, you just crank and it drills straight down into a piece of wood. So instead of having to be right on top of it, it's called a pickler triangle. It's a little climbing structure. That's what it is. Yeah, I know. Pickle triangle. So, this is what his wife wanted me to build, but then Mr. Cabillo was like, actually, could you build a modifiable pickler triangle? So now he has me building this crazy complicated thing, and it's going to be really big. But yeah, so like this. It's got like a climbing wall that goes with it. So like I'm building all of this. But yeah, so I bought a drill press, so I'm doing fantastic. None of that has anything to do with math, but thank you for asking. Yeah, well, of course for materials, and then a little extra for my work, but I mean, wood is expensive right now, like lumber's expensive, but everything's expensive.
Everyone's trying to do their own projects at home right now, which isn't a good idea.
So if you
Hence how my dad almost killed me while trying to build a loft.
I don't have to make him. That's common courtesy. So now we have actual numbers instead of on graph paper. Still the same thing, guys. Scale factor will be new over old. So when I think about scale factor being new over old, I just need to figure out which one's new and which one's old. Right, so it says from figure A, that means it's your old one. From figure A, that's your old shape. To figure B, that's your new shape. Well, that's really small. So pick corresponding sides. Doesn't matter if I pick my left sides, my tops, my bottoms, my right side. Doesn't matter. Now, I'm going to pick what I think is the nicest numbers that correspond with each other. Anyone volunteer to tell me what sides you think are the nicest, Stella? The 4 and the 1, because this is a whole number, this is a whole number, and whole numbers work nicely together, normally. At least better than like a decimal and a 6, right? So I'm going to put which one on top? The 1, because the new one goes on top. So did we get bigger or smaller here? We got smaller, right? Our new shape is smaller than the old one. Questions? I think I have something in my eye. Do the next one if you have not yet. Volunteer to tell me what numbers you think would work nice. Up here, we've already talked. Natalie?
7 and 28.
Sure, yeah. I dig it. Now, what goes on top? What goes on bottom?
28 goes on top.
Because figure B's are new shape, and new goes on top. So our scale factor will be 28 over 7. Now, do we want to leave it like that? What can we do to it? 2.
No, not 3.
Close. 7, 14, 4.
Flynn, are you available for a quick question?
Oh, good work. Any issues? Any problems? Y'all mad when we did the Desmos yesterday instead of doing like this first?
Only on Thursday.
Who? What? What names? What? Would you quit distracting everyone? We had a Jalen at Phoenix. These are just names. Now, I don't know why you're asking what is with these names. What is with people drawing a hot dog on their paper? Like, what is? That's, I don't know why you're asking about names and not that they're drawing hot dogs and chickens. All right, come back to today's notes, please. Come back to today's notes. Let's quit judging weird names because I grew up with people going, "Your name's Micah, not Michael," and I had to explain to them that it was from the Bible. So let's keep that. I know. That's my last name's easy, but first name, I spent my life saying Micah. Just say Mike and then hesitate. Micah, right? All right, so these problems I think are way too easy, and if you have like tried them and thought they're hard, you didn't read. Or you just needed to come to class, right? Because you didn't quite yet know what a scale factor was. Now that we know what scale factors are, and that's what we're multiplying with, if our scale factor is less than 1, do we get bigger or smaller? Smaller!
Anything less than 5.
Yeah, anything less than 5. All of those.
Yeah. And it's the same thing with the other one, but like the other way around.
Well, so I'm aggressive because people came to me and they're like, "You assigned all this homework." Guys, these are not hard problems. They're just making you think, okay, scale factor less than 1 gets smaller. Anything smaller. On the flip side, a scale factor bigger than 1, just anything bigger than your original number. So, okay, this one is a tough name to pronounce because it is like, well, I was about to say, it's not what we're used to. So it's difficult. I don't know, Nate, can you help us with how to say this? Is it Jingsheng? So one of the things Khan does that I really like is they incorporate non-white names, right? Our boring, like Joe, Sam, like my name is fairly boring, but like I like this. It exposes us to outside of our bubble. So, what can be the side length of the scaled copy? Ooh, wait a minute. Crap. What's a wait? What's a rhombus? But what is special about it?
It's like a diamond. Because it's like a full square.
Jocelyn, what? Natalie, what? You're both absolutely right. All the sides are the same because it's like a pulled square. So, this side length and this side length are actually equal. So, this is actually a special right triangle called a 3, 4, 5 triangle, but this is 5 because this is 5 and it's a rhombus. So what we actually see here is our beginning length was 5, but if we're using a scale factor greater than 1, pick something bigger than 5. 5, 7/3, I think this is an 8 down here. I have a dog hair in my mask. Any questions on that? Well, because I wash them, and my washing machine has dog hairs in it. Because everything I own has dog hairs on it. Ooh, that's a really good idea. Or Mrs. Golding sometimes does the tape thing, where you put tape like inside out on your hand. I should do that. I just gotta hang out with you guys. You're smarter than me. All right, so a note. The last thing on this page of notes, guys. I want you to draw a little split in your paper so you have like 2 sections to write. The next worksheet we're going to look at has things like what we did in Desmos yesterday. And what's challenging about this is when I say you have to do it like this, there are actually options for how you have to do it. So if there weren't options, that would probably be easier, right? But here is what I mean by the units have to agree. If we're going units, like we did yesterday, compared to feet, that's supposed to be an F, then that has to be equal to units compared to feet. Right, units would have to be on top, feet would have to be on bottom. Units on top, feet on bottom. But, and you don't necessarily have to write all of this down. Here's where it starts to suck when you do work with other people and you're like, wait, I did it like this and you did it like this and we didn't do it the same. You could also do feet on top, units on bottom. Equal to feet on top and units on bottom. What you can't do is flip it, right? Like feet on top and then put units on top. Like you can't do that. So you have to decide what goes on top, what goes on bottom. Essentially, what I'm saying to you is if you do new over old, guess what? It's got to be new over old. If you do old over new, guess what? Has to be old over new. So guys, you got a bunch of options. You just have to make sure things agree. So, now we move on to our new notes. So our next page, guys, this is not like 2 days worth of class. It's just I needed 2 pages. I really needed 3 pages, but I decided not to get as much. I want you guys to go ahead and take a moment to just, first off, figure out the scale factors of these next problems. So, our first one here with the triangles, if we just say that we're always going to go A to B, A is our old, B is our new. So if we're going A to B, that's old to new. Well, I haven't used cards yet today. Mia, you just so happen to be on top. What division or fraction or whatever you want to call it would I set up for my scale factor? Yeah, 10 over 4, because we see that these sides on the bottom correspond to each other. And if 10 is our new, so when we go from A to get to B, we multiply by 10 over 4, which is actually 2.5. Right? If you simplify it out, it's actually 2.5. So when I go from X to, oh wait, crap. I can't start at the thing I don't know. I don't want to talk yet today. You're real close. I think you maybe just like mixed up how you said it. Remember we said we always want to multiply. We kind of don't like division. Division is so complicated.
You multiply 11 by 4 tenths. Wait, yeah.
If you take a moment and just think about what Lacey just said.
The reciprocal of 10 fourths.
If we are going the other direction, just flip your fraction. Guys, it's like what was on the other worksheet. Way back here at the beginning. The times 2 and the times 1/2. You should be able to look at both of these at the same time because they're on 2 different worksheets. So way back here on the beginning, guys, these are reciprocals of each other. When we go the other direction, all we do is flip over the fraction. Because 2 compared to 1/2, well, this is really 2 over 1. And this is 1 over 2. Right? So now on these notes, instead of going, and what I want you to draw, instead of going from A to B and multiplying by 10 over 4, we're going to go the other direction. Now, you could talk about it like division, but we don't want to. We just want to keep everything as multiplication. We use the reciprocal. We flip our fraction. So x is going to be 11, which I'm going to go ahead and make a fraction, 11 over 1, times 4 tenths. Yeah, 44 over 10, which is 4.4. Try that over here. Hey. Yeah.
thing. Is there, does Phoenix own anything that is better than my phone recording on either?
Phoenix doesn't. You could contact Joe Norris. He's got the nice camera for the
John
district.
Taylor.
Is it now?
Joe Norris is not here.
He's gone now?
I tried to email him and like, but it's Don
He was my
Taylor.
guy. Okay. So, yeah, I would reach it. We don't
I
have
just didn't
anything.
know because like
Or
some
if we do,
schools got like an iPad kind
if
of like.
we do, Louise is your person to talk to.
Okay, she said she wasn't sure.
I-
So she was
I
like,
have
ask
nothing.
Micah if
Nope.
he has any sort of
Nope.
camera.
I
Okay.
got audio equipment. That is it.
Okay, that was my question.
Yep. Sorry, I can't be more help, but
That's okay.
just being honest. All right, so are we getting bigger or smaller here? Smaller, right? By not that much. Right? Like, going from 4 to 3 is not crazy. But, I don't know, purple. What do we then say our scale factor is? Ooh, we don't really need to convert to a decimal, but go say that again, whoever said it. Yeah, it's 3 over 4, but if we want to talk about it as a decimal, or a really cool application of that, it's 75%. Right? That's where 0.75 goes. Ooh, the new shape is 75% of the old shape. So, we are going from old to new. So this one is actually slightly easier than the one we just did. Since we're going the same direction, we use the same fraction. We use the same multiplier. So the times 3/4 is what I do over here. Or if you really like fractions, if you really like decimals, do times 0.75. Doesn't matter. I don't care. What is x then? 6.2? Hold on just a second. Check in your brain, did my number do what it's supposed to do? We said the scale factor is less than 1. Your number better get smaller if I'm going to the new shape. If I was going the other direction, our number would get bigger. There are other ways to do it, a lot of ways. We can also use proportions. Is that what you did? Because that's what I was about to show. You did what? You cannot do that. You are not allowed, if it worked out this time, it's a fluke. You are not, I'm sorry, but I'm just going to zip you on this one. You cannot add and subtract to do this. You can sometimes get away with it because it just works out because you get lucky, but this all has to be multiplication. Now, I know what you maybe did, but I don't want to talk about it out loud because it'll confuse people.
Yes, ma'am.
You know what I mean? So we can talk later. I bet I know what you did, but I don't want to talk about addition and subtraction. This is all multiplication work. Jocelyn. Is it wrong? Okay, so that's what I was worried about. It's 5 point what? 5.4. So the reason 6.2 was wrong is we cannot scale. We cannot say -1. We can't because that is not scale. Scale means everything happens proportionally. Because what I was about to check is the proportion. So guys, check this out. If we know that we're doing new over old, 3 over 4 will be equal to new over old. You guys could write this down. This is another way that always works. Literally always works. What's that mean? Now, this is just another way. If this is more confusing for you, you don't have to take it, but I would like you to write it down. My poster fell down. But we can always cross multiply. If you remember the butterfly technique, or whatever you called it maybe. 21.6. And then we would divide by 4. Right? That's another way. You don't have to take that way, but that's another way we can Questions? Try the next three. The bottom two, this one should be exactly like what we've been doing, but then the bottom two are a tad bit different. You can chat with each other. I love what's happening there in the middle of the room with Isis and Jocelyn. I dig it. What should I do? Oh, you're lucky you opened your eyes. I was about to build a tower on top of your head. If it really looked like you were asleep, I was going to start stacking stuff on top of you. That's one of the things I do when kids fall asleep in my class. Is put stuff on me.
I fell asleep in this child's class and keep banging on the table.
Yeah, well, sometimes. So, like, if Madeline was asleep, I would maybe just sneak up and just do like.
Our old math teacher, Miss Stoll, she one time a kid named Luke in our class fell asleep and showed him his yard and slapped it on his head. I remember that. She was also a teacher that I don't think I was in the class when that happened, but I think I was there and he screamed. He was like, yeah, I heard, but he didn't get hurt. Yeah, I heard.
Can we, as much as reminiscing is fun, can we just subtract 10? No, I just talked about this. We cannot subtract. Right? That'd be great. It'd be awesome. That's why we can't do it. Because, life sucks. So, we have to figure out new over old. I'm going to be lazy and just do 34. 35 over 45. Now, if I want to put effort in, I can probably reduce this since they both end in 5s. What is it?
7 over 9.
7/9. And am I going the same way or am I going the opposite way? Same way, right? To get to X, I'm going the same way. So we're going to do 27. Guys, please write down this work if you don't have it on your paper. 27 times 7 over 9. And here's why I'm having you write it down. You could grab a calculator and do this in your calculator. Or there's a shortcut here. We can cross-reduce. This poster has not fallen down. Up there, it's the poster that says cancellation. It's the dark orange one. But guys, we can always divide on top and bottom. It's like reducing a fraction. But we're reducing now instead of waiting till the end. Both of these can divide by 9. So this becomes 3, and this becomes 1. And my answer is just 21. Or grab a calculator, do it in your calculator. Questions? Since we use calculators, could I just take this 35 over 45 and this 27 and just multiply them to get my new side? Yeah. Because one thing that we haven't written down yet is your new, I need to add a slide here. Your new value, your new length, your new whatever you want to say, is always the old times the scale factor. Your new is always the old times the scale factor. That I know I got some people not writing stuff down when I am, but I think it's because you already have it written down. So I'm hoping that this all just feels a lot easier than the Desmos activity felt, and you're like, okay, now this makes sense. But do we have any questions? I only have like 5 minutes of class left.
I don't really understand what happens with
The next one? Or
no,
what?
with the was it cost reducing?
Yeah, so that is another one of those skills that we don't have to do.
Yeah.
So if we go back, no, I don't think it keeps enough memory. So the last thing I said is what we can do is just do 27 times the scale factor of 35 over 45. But that gets me a bonkers crazy big answer. And both of these are actually divisible by 45. So now I divide. I don't think they're divisible by 45 actually. Yeah, they are. I could divide by 9 like I did in the last problem, or here I can actually divide by 45. Either way, this actually comes out to be our new side of 21 that we just got. Like, so you don't have to cross reduce. But, Lacey, do you want to look for cross-reducing? 3. Both of these can divide by 3. So you can always divide on top and bottom by the same number. Or you wait till the end and do the simplification then. I want you to take the last couple minutes while I walk around and drop wipes on your desk to try to finish the front of that worksheet. If it's already done, work on the back. We're going to pick this up here tomorrow. There's always a back, Nate. I don't normally print out one-sided paper. I feel like it's pretty small. Who doesn't? Someone who's hungry, probably. Depends on the hot dog. You gotta get some like all beef fries. Dude, mustard is delicious. I don't know. Give me some brown. Some nice good brown mustard. You are welcome.
I ate a big pickle, a hot pickle yesterday. Oh my god, it was so sour.
Pickles are good too. I like anything with nice bold flavor.